Okay, so hello everyone. So today I'll be discussing some sample problems of applications of differential calculus, which is the Maxima-Minima problems. So we have here a problem which is a box is to be made of a piece of cardboard, okay, 9 inches square by cutting equal squares out of the corners and turning up the sides. So find the volume of the largest box that can be made in this way. So for So we will have a cardboard, which is a square cardboard that and each side will be 9 inches in length. So if that is a square, therefore all sides are equal. So let's say this is the square. This is our cardboard. I don't remember that is a square. And you have to make, so out of this square cardboard, you have to make a box. So if you want to make that a box, you have to cut equal squares out of the corner. So each corner will have a square. So let's say we have a square here, another one here, and another one here. Okay, so you have to cut out those squares. Okay, so I'll just draw another one so that you can see the byproduct. Okay, so cutting out squares. Another square here. Okay, there. So again, so this is the initial look of the cardboard, and you have to cut out squares in each of the corners. So after cutting out the squares in each corner, you'll have something like this. So you have to cut this out, right? You have to cut these four squares in every corner. So cutting those out, you will look like something like this. There you go. So that will look like something like this. Then turning this side. Okay. So if you will turn this up, okay, you will turn this side, and this side, these four sides, you will be able to form a box. Okay, so for instance, let's say that from here to here will be the size of that will be x. If that is x, since that is also a square, this must be also x. And all of those are squares with the same sizes. So this will be also x, 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 and x. Okay. Therefore, if that will be x, don't forget that from here to here, that will become, that is a 9 inches square. Therefore, this is, the size of this side is 9. Okay. So again, if this is x, this is also x, and this whole side is 9. Therefore, from here to here, you'll have 9 minus 2x. Okay, 9 minus 2x. Therefore, since that is square, all sides must be equal. Therefore, this side and this will also be 9 minus 2x. And that also goes from this side and this side. Okay, so after the byproduct, you'll have here will be, of course, this is also your, if you will make this a box. Okay, so remember, you have to maximize the volume, or the largest box possible can make this in this way. Therefore, for the solution here, okay, let's just provide the solution. Okay, so for the solution, of course, we all know the volume of the box. The volume of the box will be, of course, that will be length times width times height. But what are the length, width, and height? Of course, if this is the box, you will have, this is the length. Okay, and of course, this will be your width. Now, what will be the height? Since you have to turn this side up, that will be your height. Okay, that will be your height. So from the figure, you'll have your length will be equal to, your length is here, which is also 9 minus 2x. So your length is 9 minus 2x. And therefore, your width will also be 9 minus 2x. It's also 9 minus 2x. And then your height now will be equal to what? Since this is your h, or this is your h, which is also x, since that is a square. Therefore, your height will be x. Okay, so these three, you have to, let's say this is our equation 1. You have to substitute this, okay? Substitute, okay? Substitute to, of course, equation 1. Okay. So substituting that to equation 1, you'll have v will be equal to, your length is 9 minus 2x, and then your width will be 9 minus 2x also, and your height will be x. Okay, so we can I can combine 9 minus 2x. So combining those two, you'll have 9 minus 2x. Since that is just the same, you'll have squared times x. Okay. Okay, so expand. Let's try to expand. So expand. Expanding that, you'll have, okay, that's 9 squared. So that's 81. Okay, then minus 2 times 9, that's 18, times 2. That will be 36x plus 2x squared. Even though that's negative, since it is squared, this will be positive. So 4x squared. Okay, and times, we still have x outside. Okay, so distribute x. You'll have here 81x minus, okay, 36x squared plus 4x cubed. Okay, since this is now the volume of the box, and we have to make the largest box as possible, therefore you have to maximize this one. So you have to maximize. Okay, so maximize. So maximizing this one, you have to perform derivative. Okay, so first derivative. So first derivative, that will be a derivative of v with respect to x, right? So that will be dv over dx. Okay, so derivative, you'll have 81 derivative of 81x, that will become 81 minus, that's 36 times 2, so 72, just power rule. And now derivative of 4x cubed will be 12x squared. So remember, if you are maximizing that, again, dv over dx, or the first derivative, is also equal to the slope of the curve, or and the tangent line touching the curve at that point, the slope of the slope of the tangent line will be 0. Therefore, dv over dx will be also must be equal to 0. Therefore, 0 will be equal to this one. I will just rearrange this equation, since 12x squared is at the last term. I will just make it to the first term, 12x squared, and then followed by 7 minus 72x, 72x, and then plus this one, plus 81, plus 81. Okay, so all you have to do here is solve for x. Okay, find x. Okay, no. So you just need to find x here. So how will you find x? Okay, so find x, since that is a quadratic equation. Okay, find x. Use what? You can use quadratic formula. Just call it QF. Okay, QF. Find x, use quadratic formula. If you will use a quadratic formula, of course, since that is a quadratic equation, you'll also have two values of x. And after using that, you'll have, I will no longer discuss how to get the x, but if you, after getting that, the value of x will be um, 1.5 and x2 will be 4.5. 4.5. Okay. So getting that, again, we have the volume. The volume is 9 minus 2x and x. So these values substitute. No? Okay. Substitute to v. This one. Okay. Dito. Next, after that, substituting, you'll have, let's try, okay, try 4.5 x2. Try x2 first. Okay, let's just try x2 first. So trying x2, you'll have v will be equal to 9 minus 2. Okay, 9 minus 2 times the value of x is 4.5, right? So 4.5. Don't forget the squared. Squared times x, which is also 4.5. Now, as you can see, 9, that's 2 times 4.5, that will become 0. But we all know that it's impossible that volume is 0, since we know that we will be able to create a box. Therefore, um, v equal to 0. Okay. Therefore, what we will do is we have to disregard x2. Therefore, we cannot use x2. Okay. So disregard x2. Okay. Disregard the value of x2. Okay. Disregard the value of x2. So if you will disregard the value of x2, I'll just put some there. Therefore, we are forced to use x1. Use x1. Okay, so using x1, you'll have v now will be equal to, that is 9 minus 2 times, which one? This one. 1.5. 1.5. Don't forget the squared times another 1.5, but that will be another x. And if you will get that, you'll have v equal to 54. Okay, 54, that is in inches. So this is 54, since that is a volume, that is inch cube. Now, so this is the right answer. Okay, so this is your right answer. Now, if you want a shortcut, we can have here a shortcut. Okay, shortcut. The shortcut for this one, for this specific condition, is you'll have the formula will be v equal to 2 over 27 s cube, where s, where your s is your side length. Okay, so your s will be equal to, is the side length. Side length. Okay, therefore applying this shortcut into this one, into this problem, you'll have v now will be equal to 2 over 27, and remember that s is given here. S here is 9. S equal to 9. Therefore, this will be 9 cube, right? It will be 9 cube. And if you will use your calculator here or just mental, okay, that will also give you 54. Okay, so on to the next problem. Okay, so here we have another problem, but it's almost the same, but now the dimension of the cardboard now is no longer a square. So find the volume of the largest box that can be made by cutting equal squares out of the corners of a piece of cardboard of dimensions 15 inches by 24 inches and then turning up the sides. So the figure will still be the same, but the difference now is it's gonna be a rectangle. Okay, so it's gonna be rectangle, and again we still have some squares that will be cut out. So it will look like something like this. But now remember that this side that will become, since that is the longer side, will make this 24. This is 24 inches, and then this side, okay, will be your 15 inches. Okay, so still these squares are equal squares, and let's still say that each side will be x. Okay, x. Okay, so this will also be x. Therefore, from here to here, that will now become 24 minus 2x. Okay, and this side now will become 15 minus, okay, 2x. So this will become your length, and this will become your width, and your height is still x. So, so again, the problem is still almost the same. There's just a little bit of difference, but the volume of the box will not change. That is still length times width times height. Okay, so from that, your length will be 15 minus 2x. Okay, 15 minus 2x, and your width will be 24 minus 2x, and your height is, again you have to turn this side up, and your height will still be x. Alright, so now we can substitute this. Now say this is our equation number 1. Okay, so substitute. Okay, substitute to equation 1. Okay, to equation 1. Okay, so substituting to equation 1, you'll have, so your V or your volume now will be equal to your length. So if ever your length and width will be interchanged, let's say your length will be 24 minus 2x and your width will be 15 minus 2x, the answer will still be the same, so there's no problem with that. So you'll have here 15 minus 2x times, okay, 24 minus 2x. That will be your length, width, and of course times. Okay, let's just write this. It's 2x times x, and this will be your height. So that's, again, that's your length. This is your length. This is your width, and this will be your, again, your height. Okay, so that's length times width times height. Okay, so we have to expand. Okay, so we can use FOIL method. Now that's 15 times 24. That is 360. So that's 300. Okay, 60. And then 15 times negative 2x, that will become 30x. And then negative 2x times 24, that's minus 48x. And minus 2x times minus 2x, that will become 4x squared. And of course, we still have x on the outside. So combine like terms, you'll have I will now combine negative 30 and negative 48. That will become 78. And I will also distribute x at the same time. So you'll have here 360. That's times x. So that's 360x. Then 30 minus 30 minus 48. That will become 78x. Okay, 78x. And then plus 4. Oh no, this must be squared. This must be squared. Okay, so we have to times it by x. And this is cube. Okay, so again you have to maximize this one. Maximize. You have to maximize the volume. So this one must be okay, maximum. Therefore, perform derivative. So performing the derivative, you'll have dv, or the derivative of the volume, with respect to x. Therefore, you'll have here okay, 360 minus a derivative of 78 x squared will be 156. So 78 times 2, that is 156x plus 12x squared. I think this is all divisible by 12. So again, I will just rearrange this, rearranging that you'll have 12x squared, okay, this one, then minus this one. I'm just rearranging the order, and then this one plus 360. And again, dv over dx, or at the first derivative, this must be equal to 0. I think 156 is also divisible by 12. So dividing all by 12, you'll have x squared, and let me just use my calcu. 156 divided 12, that is 13. That's minus 13x plus, I think this is 30. Okay, just to be sure. Okay, so divided by 12, that is 30, right? That's 30 equal to 0. So from this point, all you have to do is just find the values of x. So if you will find the values of x, okay, so find x using, again, quadratic formula. Or you can just use your calcu if you are allowed to use it. Using quadratic formula. Okay. That your x1 will be 3, and your x2 now will be 10. Okay. So substitute both of these. Okay. Substitute to the value of the volume. So again, value of volume is this one. We can use this. So at x equal to, let's just try out 10 first. 10. Trying out 10. You'll have v will be equal to, this is quite long, so 15 minus 2 times 10. Okay. And then times 24 minus 2 times 10, and then times 10 again. Times 10. As you can see, if you will now calculate this, that will 15 minus 2 times 10, that's 20. So 15 minus 20, that will be negative. So this is negative, and this is positive. This will become positive. So we don't need to um, compute this anymore, because whatever the value of this one, it will become negative. But we all know there's no volume is negative. Okay. Therefore, what we will do is, of course, we have to disregard x equal to 10. X equal to 10. Okay. Therefore, or hence we can use x equal to 3. Okay, so using x equal to 3, you'll have v equal to, that is 15 minus 2 times 3, and then 24 minus 2 times 3, and then times 3. Okay, so that will become v equal to, that is 6 times 15 minus 6, that is 9 times 24 minus 6, that's 18, and then times 3. Let me just use my calculator. 9 times 18 times 3. That is, therefore your volume will be 486 watt. That is in inches, so therefore this must be inch cube, and that is your final answer. Okay, so on to the next problem again. Okay, so for number 3, we have two posts, one 8 feet high and the other is 12 feet high, stand 15 feet apart. So there are to be supported by wires and attached to a single stake at the ground level. So the wires running to the tops of the post. Where should the stake be placed to use the least amount of wire? Okay, so what will happen here is the figure should looks like something like this. Okay, so we have, here's the first post, and then here's the, okay, so here's the second post. Okay, and then there's a first post, and here's the second post. It should be higher, right? So the other one is 8. The first one is 8, the other one is 12, and they are 15 meters apart. So we can say that this is the first post. So this is 8 feet, while the other one is 12 feet. Okay. Therefore, there are the wires running to the tops of the post, and they are attached to a single stake. So what do you mean by that? By the single stake is they will be attached. The wires from the tops of the post will be attached on a single point, which is at ground level. So let's say that this is the point. Okay, this is the point. Therefore, we have a wire on the first post from the top of the first post. No, sorry. Okay, so we'll have a line. So from the top to here. Okay, so that's the first one. And then from the second post to here. So that would look like something like that. And then remember that they are, so from here to here, they are 50 meters apart. No, 15 feet. Sorry, that's 15 feet. So this is 15. Okay. So if this is 15 meters, we are looking for where should the stake be placed to use the least amount of wire. Okay, so let's say that this is x. This is x. Okay, if this is x, therefore this must be, so from here, this is x. Okay, if this is x, therefore this must be 15 minus x. Right, this is 15 minus x. Okay, so remember that there are wires attached. So from here to here, that is a wire. So this line is a wire. Also, from the top of the second post and to here is also a wire. Now we are asked to find um, least amount of wire. So the amount of wire must be minimized. Okay, so if we will call this part, let's say this is L1, and this second part, let's say this is L2. Okay, the hypotenuse. Of course, this is obviously a right angle, and this is also a right angle, right? So from the first triangle, so from the first triangle, okay, from the first triangle, okay, we can have there a Pythagorean theorem, right? So use, sorry, nope. From the first triangle, use Pythagorean theorem, okay? Use PT or Pythagorean theorem, okay? Use Pythagorean theorem. You'll have here, you'll have 8, right? That's 8 squared plus 15 minus 15 minus x, and that must be squared. And this is all equal to what? L1 squared. That L1 will be your hypotenuse, L1 squared. Okay, so let's try to expand this one. So expanding that is, I'll just write L1 squared first, then 8 squared is 64. Okay. Plus, oh, I can't do 15 squared. Okay, let's try 15, no, 15 squared is 225. That's 225, 225 minus, that's 15 times x times 2. So that's 30x, right? 30x plus x squared. Okay. Therefore, we can have, finding L1 or isolating L1, you'll have 64. That's 64 plus 225. That is 289. I'll just write x squared first. X squared minus 30x. Okay. And then plus 289. That's 289. Okay. And then, okay, eliminating the squared here, all you have to do is just take the square root of both sides. So you'll have here the square root. Okay. Or for simplification, we can just use a raised to 1/2 instead of square root. Okay. Let's just use a 1/2 for, so that you can easily see, or you can easily get the derivative of this one later on. Okay. So for the triangle number 2 here, let's say this is equation 1. Okay. We can have from triangle number 2, um, triangle number 2. Okay. Okay. Again, use Pythagorean theorem. You'll have here x squared, okay, plus 12 squared, right? This 12 and this x. This must be all equal to the hypotenuse L2. L2 squared. Okay, so expanding this one, you'll have here again L2 must be equal to x squared plus 12 squared is 144. 144. And of course, this must be raised to square root, or that is also equal to 1/2. Okay, let's say this is our equation number 2. Okay, this is our equation number 1. And of course, you have to minimize. You have to minimize or use the least amount of wire. So the total, let's say let L be amount of wire needed. Okay, amount of wire. Okay, therefore L must be equal to the total length of wire, which is L1 plus L2. L1 plus L2. Okay. So from here, we have to substitute. Okay. Substitute here the substitute 1, equation 1 and equation 2. Okay. Therefore, you'll have here, this is quite long, I think. So, okay, I'll just make a divider. Okay. So you'll have here L now will be equal to L1 is this one. So you'll have x squared minus 30x plus 289. This must be raised to 1 half. Plus now, this one. This is the equation 2. Now you'll have x squared plus 144, right? And raised to 1 half. Remember, so now we have this equation. Remember that this is the amount of wire. And the amount of wire must be, you have to use the least amount of wire. Therefore, this must be minimized. To get the minimize or the small amount of x, this must be sorry. Okay. Not necessarily minimize. We can just put here minimum. Okay. This must be minimum. Okay. So if order for you to get the minimized value of this one, you have to use derivative. Okay. So derivative of this function. Okay. Derivative of that will be, of course, that's the derivative of L with respect to x. That's dl over dx. Must be equal to, that's only power rule, right? Power rule, 1 half will go down times this one. So x squared minus 30x plus 289. Then 1 half minus 1. So that will be negative 1 half. And times the derivative of du. So derivative of x squared minus 30x plus 289. That is 2x minus 30. Okay. And then the derivative of this one. So derivative of that one will be plus. Okay. So 1 half will go down again. 1 half times x squared plus 144. Again, that's 1 half minus 1. That's negative raised to 1 half. And the derivative again of x squared plus 144, which is 2x. Then, of course, again, if you have to minimize or get the maximum amount of any values, you have to, the first derivative must be equal to 0. So this must be equal to 0. Okay. So therefore, you will have um, 1 half. I'll just factor out the 2 here. Okay. Factor out 2. So you have 2, and then you will be left with x minus 15. Okay. Then times this one. Okay. Then times this one. But since it is a negative exponent, I can just write it down. I'll just put it down. Okay. I'll just put it down here. So you'll have here x squared minus 30x plus 289. Okay. So we can cancel out 2, right? Let's just change the color. Yellow. Cancel out. Cancel. That's the reason why I factor out the 2. And then plus now, plus this one again. That is, we can cancel out 2 here already. We have 2 here and we have 2 again on the denominator. So we can cancel that already. So that will be, again, that's x. And this is a negative exponent. Oh, I forgot to put here. Sorry. Forgot to put here your raised to 1 half. Now the 1 half now will be positive, right? Will be now positive. Plus, since I want to bring this down, I have to bring this down. That's x squared plus 144. Okay, so this will become positive raised to 1 half. Okay, and then, so 2 is already cancelled. We'll just have here x. This must be all equal to 0. Okay, so now you'll have, so from this point, you'll just have x minus 15, x minus 15, can just erase that parenthesis. And then this is, for simplification, let's just use square root. So x squared minus 30x plus 289, okay, plus x square root of x squared plus 144. This must be all equal to 0. Then from this point, all you have to do is just find the values of x, and I guarantee you that this will be a quadratic equation. So you can use quadratic formula, or you can just use your calcu using the shift solve function. So after finding that, I guess you just have x1 must be equal to 9, and the other one will be equal to 45. Okay, so which one is right? So therefore, the x will be either 9 or 45. Okay, so from that, of course, we cannot use 45 because 45, again, the two posts, they are only apart by 15 feet. Only 15 feet. So therefore, it's impossible to have 45. Therefore, this one is wrong. Okay, disregard. Okay, disregard 45. Disregard. Therefore, your right answer is 9. Okay, that's your final answer. Remember that this is 9. Therefore, your answer will be, I'll just put it right here. Therefore, your answer is 9 feet from 12 feet post. 12 feet post. Okay, so that is your answer. Okay, so I can see that the solution is quite long again. So I was able to derive a formula, a shortcut. Okay, so I'll just erase some of these. Let's just erase this part. Okay, I'll just erase this part. So erasing this part, I will just rewrite this one. Okay, okay. So just writing, you'll have here a triangle and a higher triangle. Oh no. Okay, so it seems that I cannot do it like that. Let's just draw another triangle. So a higher triangle. Oh, okay. And another here. And then a straight line down. Okay, so from here, the formula, the shortcut will be, oops, the shortcut, in order for you to be able to solve this fast, I'll just delete this again. The shortcut will be x now will be bd over a plus b. Okay, just remember here that b must be greater than a. Okay, so b and a are the height of the post. Therefore, this is your b and this is your a. And d will be the distance between the two posts. So this from here to here will be your d. Okay, so using the formula here, you are using the shortcut that I was able to derive. You'll have b is 12 and d is 8. No, it's 15, sorry. Okay, 15. And a plus b, so that is 12 plus 8. That's 12 plus 8. Okay, so using your calculator, you'll have times 15 divide So that's 20, right? You will also get the same answer. 9 feet. Okay, 9 feet. Just remember that x is the distance. Okay, distance from the taller or higher post. Okay, taller post. Okay, this is a shortcut. And this is your answer. Okay, on to the next problem. Okay, so for our next problem, we have the fourth problem, and I think this will be the last problem for maxima-minima problems, sample problems. The perimeter of an isosceles triangle is 4 inches. Find the maximum area. So the area must be maximized. So the figure will look like something like this. Of course, since that is a isosceles triangle, remember for isosceles triangle, two sides are equal. So this side and this side are equal, and this will be a different length. Okay. So let's just say that this side, okay, this side up to this side, up to this side. Let's just call this A. And of course, this is also A. And since this is a different one, let's just call this B. Or that will also stands for the base of the triangle. So this is your base. Okay. Now, what will be the area of that? The area of that triangle, of course, we can just use the simplest one, which is the 1/2 base height. 1/2 base times height. And what is the length of the height? Of course, that is from here to here. That will be your height. Okay. That will be your height. This one. And of course, this is a right triangle, right? And this height will obviously cut this B into two parts. Of course, if of course this to here, that will become divide 2 of the base. So this is your base over 2. Okay, base over 2. Now isolating this triangle, you'll have a separate triangle, right? So you'll have here, nope, something like this. And then you'll have, of course, this side is your A. I'm just rewriting this figure. This part, this triangle. This is your A, this is your H, and this is your B over 2. Okay? So again, this is your area, 1/2 BH, and this must be maximized. This must be max. Therefore, you have to perform derivative. But don't forget that you cannot perform derivative of 1/2 base height yet because you still have two variables, which is B and H, which is the base and height. Now, of course, you have to be able to make this equation into one variable, into only, is either you make this only in terms of B or in terms of H. Okay? Now, using this triangle dito, of course, we can use PT or the Pythagorean Theorem. Using the Pythagorean Theorem, we'll have here that is, of course, H squared plus, that's B over 2 squared, all equal to A squared. Okay? So from this equation, isolate, we can isolate here. We can isolate here either B or H. Okay? But I think it's easier if we will isolate H. Isolate H. So isolating h, you'll have a squared plus that will become b squared over 4 equal to a squared. So we can just transpose b squared over 4. You'll have h equal to a squared plus b squared over 4. Okay. Of course, to eliminate the squared here, all you have to do is just square root both sides. Okay. So this is your h. Okay. Then next, let's just call this. Let's say this is our equation 1, the area, and this is your equation 2. But we know that the perimeter of the isosceles triangle is 4. Therefore, say that the perimeter, let's just use a P. Of course, the perimeter of that triangle will be the sum of all sides, which is A, A, and B. So we can have here 2A plus B. But we know that P, or the perimeter, is equal to 4. Therefore, we can also say that 2A plus B is equal to 4. That is equal to 4. Therefore, you can have here 2A plus B equal to 4. Okay. Now, I think it's better if we will isolate B instead of H. No, we can isolate A instead of, no, okay. So I think it's better here to isolate A. Okay. So let's replace this one. Okay. So isolate A. Isolate A. So if I will isolate A here, I will have a terms of H and B. Okay. So you'll have here, so A now will be equal to H squared plus B squared over 4, then square root. And this, let's say this is your equation number 2. Okay. So from here, substitute equation 2. Equation 2. Okay. So you'll have here 2, and your A is this one. Your A now will be equal to H squared plus, sorry, this is B squared over 4, okay, plus B equal to 4. Okay, so from this point, you can either isolate H or isolate B. But let's just, no, let's just see if which one is easier to isolate. First, the goal here, if you are encountering a square root, the goal here is you must be able to square the square root, because if you will able to square the square root will be cancelled. So for simpler method, just isolate this part. Okay, so isolating the square root, you have to transpose B. So transposing B, you'll have 2 times H squared plus B squared over 4. Okay, then of course this is a square root equal to 4 minus B. And then, of course, squared. Squared the whole equation. Therefore, you'll have here 2 squared, that will now be 4, and then the square root here will be cancelled. So this now will become H squared plus B squared over 4. And this will become now 4 minus B squared. Next, distribute 4. So you have here 4H squared plus B squared, right? 4 now will be cancelled. And this is equal to, expand, that's 16 minus 4 times B times 2. So that is 8. 8B plus b squared. Okay, that's b squared. Next, we can cancel out this one and this one since it's just the same. So 4h squared equal to 16 minus 8. I think I can factor out 4, right? So factoring out 4, you'll have 4h squared equal to 4 times 4 minus, no, 2b. Sorry, that's 2b. That's 2b. So cancel 4, cancel 4. So h squared now will just be equal to 4 minus 2b. So I think it's easier to isolate b, right? So isolating b, you'll have, so transpose 2b, you will have b equal to, that the h squared will be transposed 4 minus h squared all over what? 2, all over 2. Okay, so what we will do is this one, substitute this one to equation 1. Okay, so substituting that to equation 1, you'll have, okay, so I'll just put here, there. A now will be equal to 1 half. B is equal to this one. Okay, so that's 4 minus h squared over 2. That's your B times h. Okay, so A now will be equal to, okay, so all we have to do is just distribute 1 half and h at the same time. So for you to be able to have, so h times 1 half, you will have h over 2, right? So I'm trying to break down this algebra for you. So 2, we can split 4 and 4 minus h. That will become 4 over 2, that is just 2, and minus h squared over 2. There, so that you can able to see it clear. So dA now will be equal to, so h over 2 times 2, that is just h, right? Then minus h cubed over 4. Remember that this area must be maximized, therefore you have to perform derivative. Now you can perform your derivative since you only have now one variable. Again, you cannot perform derivative here at first because you have two variables which are b and h. Now you can now perform derivative here because the only variable you have is h. Okay, so derivative that will become derivative of a, that will be become this with respect to h, that is 1 minus, that's 3/4 h squared. And again, this must be equal to 0. Okay, so you'll have here 1 minus 3/4 h squared must be equal to 0. So find h. So finding h, you'll have here, h now will be equal to, okay, so I'll just break it down for you again. So you'll have here 3 over 4 h squared must be equal to, transpose this one on the other side, 1. And then you'll have h now will be equal to 4/3. No? Okay, 4/3, then square root. Okay, so square root of 4 over square root of 3. So your h now will be equal to 2 over square root of 3. That is your height. Okay, so I just have to delete some of this one. Okay, so deleting this part. Okay. Okay, so delete. Okay, so deleting that and continuing. So since we already have the value of h and we have b, so b now will be equal to, no, we can now use the value of, first the value of area here. The value of the area is this one. And now substitute h, value of h, okay, value of h. Therefore, you'll have a now will be equal to 2 over square root of 3 minus, that is 2 over square root of 3 cube, cube all over 4. Okay, so all we have to do is simplify this one. So simplifying that, you'll have square root of, this is square root of 3 minus, that is 8 over tatlong square root, that is 3 square root of 3 all over 4. Okay, therefore you'll have here 2 over square root of 3 minus 8 over, that's 3 times 4, so that's 12 square root of 3. We can still cancel this out, right? 8 over 12. So this is equal to 2 over square root of 3 minus, that is divisible by 4, right? That's 2 over 3 square root of 3. And then all we have to do is again add these two. So you'll have here 3 3 times this one, that is, no, sorry, 6 square root of 3. Again, that's 3 square root of 3 times 2 minus 2 times square root of 3. We'll have 2 square root of 3 all over square root of 3. That's 3 all over 9. And then this must be equal to, oh, this is 4 square root of 3 all over 9. And this must be your answer. Okay, let's just put some units. So your answer will be this one. So that is an area, so that's inch squared. Okay, so just we have a shortcut. Of course, we have a shortcut. Let's just delete this one. Okay, delete this one. So for the shortcut, okay, so let's try out the shortcut. This is a short method of answering this one. So as you can see, again, it's quite long. The shortcut is square root of 3 p squared all over 36. Just remember that p here is your perimeter. It's your perimeter. Okay, so again, using this formula for that, you'll have your p here is 4. Okay, so p is equal to 4. And then applying that, you'll have here a equal to square root of 3 times 4 squared all over 36. That's just 16 over 36, which is also equal to 4 over 9 square root of 3. Of course, this is inch squared. So that's the shortcut. Okay, so I think I was able to solve 4 problems, and I'll be doing a next video for a related rates, that is also a application for differential calculus. So again, thank you for all watching, and see you on the next one. Bye.